Okay, it's working. So the first thing, let's talk about Al's, let's see, how can I pull up my Slack stuff here? Slack. Random. I should have had this pulled up.
Well, I mean, while you're doing that, the way I'm thinking about it is, the previous conversations were we need to have the low-level steering controller take command velocity angular statement that basically says steer to a certain, you'll probably correct me, but to steer to a certain angle.
Well, at this point, I'm not talking about steering. I'm talking about your velocity is wrong. That's the first thing I posted. So let me see if I can get this to come up. Let's see if I do that. If I do this and this one, get these out of the way. Well, the thing I just posted, I pointed out your velocity is wrong. So if you come look at this, this is where you're driving around. So you're driving around the top one here. You're driving around, I assume, to the left, and down here you're driving to the right. Maybe it was the opposite direction or whatever. But if you look over here, this is coming out of your joystick, and your joystick is saying 100% during the first circle and 50% during the second circle. Now, I don't know if you intentionally tried to slow it down during the second circle. There is some kind of a button on the joystick in that driver that you push it, you can say set the speed to 50% or 30% or something. So it could be that you were pushing that button and didn't realize it, or you had to set your joystick to 50%. So I wanted to ask how, if you intentionally tried to slow it down while you're doing that. That was my first question.
No, I didn't intentionally try to slow it down. The joystick is so no, it's programmed to take two speeds, higher, high or low, 0, all
or
in.
what?
Yeah.
Okay.
Well, three speeds, 0, 0.5, or 1.
When does it put out 0.5? What's the? You just have it. You put a scale in there, something to do that, or is it 0.5 times whatever? So it just half speed, or is it you have it programmed in for 0.5?
I believe it's 0.5 on, the actual axes reading. I'd have to pull up the code, which I'm on the wrong machine to be able to do that. But
so anyway, that's the first problem. Your joystick was putting out a 0.5 instead of a 1 during part of the time you're driving around. So if you thought you were driving full speed the whole time, that's the first thing to look at to see why it was doing that. And if we look down here, then the command velocity is scaled exactly the same. And down here, you have something called transmission PWM.
Yeah, so when
it might have been called PWM effort or whatever. So you scaled this one, you scaled the PWM to that. So
yeah,
it did make it all the way through there. But you look at the final results down here, and the first circle, you're going around 1 meter per second, and the second time you're going around 1 meter per second. So up here, your joystick said go 50% or half a meter per second, and you're still going a full meter per second. And as I was typing this up, I figured out what your problem probably is here. This is the second problem, that if you look at this, I'm guessing when you wrote down the values for your RC servo, I'm guessing this line right here is at least 100%, and then the top one is beyond 100%. So you simply maxed out the physical range of your transmission. So you come down to a certain point, and then it will start slowing down. But I'm guessing even this value that got scaled from 50% or 0.5 meters per second got scaled to this. I'm guessing that's at least 100% on the servo, and then this top one is beyond 100%. And that would explain why you're getting the same velocity of 1 meter per second here and 1 meter per second here, even though the joystick said to run it half a meter per second. So go back and remeasure your transmission to see where you keep increasing the number, where does it stop increasing? I think you've just gone beyond the limit of what the transmission will run that's what this graph is showing me here.
Yeah, I mean, the tractor will definitely run faster than what I'm running it. I have just chosen to keep it going slow. I mean, the darn thing will probably run 2 meters a second. I just didn't want to run it that fast. So
well, then you have another problem then, because this is telling it to drive. Well, for whatever reason, your transmission is not honoring what your PWM signal is. That's my point. So if you look down here, it runs the same speed the whole time, even though the PWM is changing and your joystick put in a half speed or put in a 0.5 meters per second. So
yeah,
you got a couple of things there.
Yeah, I have chosen not to give it a 2 meters a second PWM value. So that transmission PWM value of 1550, I purposefully didn't want it going any faster than that. And I just, what you're telling me is my 50%, there's not any material difference between my 50% and 100%, which, yeah, I can.
So these two bottom plots says your transmission is not honoring what the RC servo was telling it. That's what this is showing you here, for whatever reason. And it could just be you don't have enough resolution on the, I don't know. I've never seen your thing run. I don't know how far, what angle that's moving the arm back and forth. It could just be that you're not moving it far enough for the transmission to care. So I don't know. There's something odd there about you're telling it to go one speed and then you tell it to go a different speed. Yet it goes the same speed the whole time. So there's something funny about the mechanically between the RC servo and the transmission, I think.
Right. That's exactly I think you're exactly right. I'm not moving the arm enough for the transmission to care on high versus low speed. There's got to be a bigger delta there for it to care.
An experiment you could run, you could just have either write a program that talks to the servo directly, or you could go all the way back to your command velocity. Just tell it to go from 0 up to whatever, say 1 meter per second. Just have it ramp up, like say 1/10 of a meter per second or whatever, and graph that. And then when you get to the top, let it drive for a little while and then let it ramp back down to 0. And then look to see if the PWM you're plotting matches the speed coming back out of the transmission. And that might tell you something right there. Just watch to see, is it following like it's supposed to? And maybe you've done that before. I don't remember.
I did. I had I've never had a good PID. I had Matt's, partial PID, and I never took the time to write a better PID. And so I just stripped that out and put in the hard coding, which effectively is what this is. And so what you're seeing is hard coding speed control and using parameters, and yeah, it's just something I've never.
Yeah, so what I'm suggesting is at the lowest level, you do this ramp up and ramp down, and then plot out the results, and that'll tell you if the transmission is following your PWM you're putting into it. Because it might come up like this and then kind of ramp off like that instead of the other one while the other one's still going up. I don't know. That might be a worthy experiment. So regardless of any putting PID or any kind of feedback on top, just simply setting the RC to a certain PWM, what is the velocity of that basically is what you're going to be finding out. Because if that doesn't track, then you might have it. You could try all those correction factors you want, but if it's not working right to start with, you may never get that to come out the way you want.
I wish I had a long straight airport runway to just let it run.
You might be able to put that up on a, you can't put it up on a jack because if, I assume this slash speed is your value from GPS.
Yes.
I asked that on one of the posts, you didn't respond, but later you put up a graph, said, okay, now we're going to add in the speed from GPS, and you had it marked speed. So I was out digging through the Google Drive, and I think I found where you're experimenting, you were subscribing to like the GP RMC message and pulling off the ground speed and publishing that, I think is what you're doing there.
Yes, that's ground speed.
Because when I went through the trouble to take the slash vel message from the driver and break the speed out of that, and that was matching your speed. So I was suspicious that's what that was.
That's GPS direct.
Okay. So I was gonna say you could just put it on a block. No, I guess you can't. So because that wouldn't give you the GPS speed. But I think that would be a good experiment to do if you've got time in the room to do it, just to see if the transmission is following the, that would also give you an indication, is the transmission linear, say from stop to whatever speed you go to, is it linear, or is that a curve, some weird curve to do that?
Mm-hmm.
So anyway, to back up, this was your second problem, that your transmission doesn't seem to be honoring the PWM, and then the first problem is back on the back up here where you, for some reason, your joystick's putting out a 0.5 instead of a 1, and you weren't aware of that. So just by looking at your plots, I noticed that it was doing that. So that, I guess that's all I had to say about that.
Yeah, that, that one is caused, if I'm again trying to make a hard left on a joystick, you're like 90 degrees left or 90 degrees right. That's I think that's a function of where you're at on the joystick.
So again, we just switched topic. Now we're talking about steering instead of velocity, apparently.
Well, if you think about the physical nature of the joystick, you've got one I'm not using two thumbs.
Well, let me make another statement here. After looking at this, I went back to look at the, I know I several times I asked, how do you have your speed scaled? And you say, yes, you have it scaled to meters per second, but you're feeding it plus and minus 1 from the joystick. Because I went back and looked at the joystick code, and every axis on the joystick puts out plus and minus 1. There's no attempt there to scale that to anything in the real world. It puts out plus and minus 1. So you just pass that plus and minus 1 down to your vehicle, and it says, oh, that's plus and minus 1 meter per second, because it assumes it to be a speed in meters per second. Just like your steering, if you pass the steering as an angle, it'll say, oh, that's plus and minus 1 radian, because again, you are taking the plus and minus 1, which is the equivalent of, say, plus and minus 100%. He just used 1.0 as opposed to 100%. Because he was using a floating point number. So you just directly fed that in there. So by default, that means your speed goes from 0 to 1 meter per second, because your joystick arbitrarily puts out plus and minus 1. And same thing on your steering. Your steering puts out plus and minus 1. That's just a number. That's basically plus and minus 100%. That's why in between your steering, you have to take that plus and minus 1 and scale it to be whatever angle you want the steering to turn at. So it could be up to this point you hadn't realized that it just magically works, taking the forward velocity of plus and minus 1, and your vehicle moves, that you haven't actually scaled that anywhere in between there. So just don't think that you have. It says, oh, here's a number coming in as a speed. I'm assuming that speed is meters per second, whereas your joystick says, no, it's just plus and minus 1. It has nothing. It's non-scalar, is that the term they use?
Yeah, so my joystick isn't, it's not. I'm clear. My joystick is not sending a meters per second signal. It's just a number.
It puts out a number, and your tractor just assumes that it's meters per second. That was my point. If you actually want to scale that to something in something real, you can put a scale factor in between that. So eventually, if you want that to be the joystick to be in meters per second, just put a scale factor between the joystick and the vehicle, and the steering, you're going to have a scale factor that says, take the joystick and scale it to this angle. So by the time you're done, It seemed to me he should have put in his joystick code, he should have had a parameter that said, instead of plus and minus one, here's a scale factor. So you can run those up and down. You can scale them any way you want by just setting a parameter. But I looked and I don't see that in there. So apparently his joystick just puts out plus and minus one regardless. And it's up to you to do whatever you want with that.
Yeah, I know how, me driving in a circle, trying to get a hard left and a hard right could generate a hard left and 50% on the speed by the physical nature of the joystick and my thumb and the placement of my thumb on the joystick. I mean, I understand how that's physically happening.
Well, it seems to me that it should be symmetrical, whether you turn it right or turning left. It seems like that shouldn't affect your speed.
No,
Yes. If you got the joystick pushed all the way up for forward, it should run, regardless of whether you're turning left or right, I think.
What you're probably assuming is I have a joystick with speed on one axis and steering on another axis. I have speed and steering on one axis.
I have the same.
And I also have the same, but I'm just thinking if you're using that little gamepad, it may be a little deceptive as to where you may not have been conscious to push the thing all the way. You moved it, say, to the right, but you may not have been conscious to push it all the way forward. So it could be that's just what it is, that little joystick, and you weren't obvious where it was. But you could fire that up and just say, fire, like, say, Ross topic echo, and watch the values coming out of the joystick and just run it around and and try to repeat what you did and see if that could easily give you the wrong speed.
Well, I mean, stated simply is, if I push the joystick to, effectively 12 o'clock on the joystick, it's going to go straight. If I push it to 9 o'clock, the wheels are going to turn left, but it's not going to move. If I push it to 10 o'clock, it's going to move, but it's not going to be a hard left.
Yes, you give an excellent example. I have the same. And it's very understandable if you use the, the clock. You have to put it at 10, between 10 and 11 to get the tractor moving to the left and forward.
Okay, I understand what you're saying now. And it might be nice to just dump that out as a, dump it out and watch it, and just watch the joystick itself and see how that acts, and see if that is what your problem is.
In my robot, when you push it to the 9 o'clock, the robot won't move. If you were going forward and you push it to 9 o'clock, the robot will stop, because the actuator that was pushing the gear lever for the transmission needed to be to get the instruction of the 10 between 11, pointing to 10 between 11.
So we're going to chalk this up to operator error. Now, another point to notice here, or another point to make, is you didn't notice that you had it in the wrong spot because your steering or your speed down below was not honoring it. So it was going the same speed either direction. It's just that so there's no indication back to you as going too slow, so you didn't move the joystick anymore.
That's a very good point. I mean, I can adjust my parameters and transmission settings so that it's more apparent when my joystick needs to be moved around a little bit.
I don't think it needs to be more apparent. It's just the fact that your transmission is not following the input request. So whether that's scaling or modifying the code or whatever, because if you set it to 0.5 meter per second and it's still running at 1 meter per second, there's something funny going on there. So you just had no visual indication as the operator that it was going too slow, or you could have moved the joystick to speed it up again. I think just something to think about.
Yeah, it's good feedback.
So I just happened to notice that I actually noticed this right after you posted it. I first started looking at stuff that doesn't look right, but then I never got around to posting it. But that since we had a meeting today, I'd write it up and then post that. So I think that we pretty much beat that to death, unless somebody has any more questions on that. And yes, I see your point about the joystick. As you move it around, it doesn't give you like a square, on the joystick, you don't get a square pattern. It's actually a circle. So as you move around, yes, as you go full left and you try to get to the top, it actually starts. I suppose your steering would actually come back in too if you say full forward. Well, if you say full forward, your steering is 0. So I guess, yeah, that all makes sense. So anyway. So does anybody else have anything to say, or should I move on with my stuff?
Well, I'm still interested in any counsel you want to offer about how to calculate angle from the data that I've gathered. I mean, so here's what I know. I know my vehicle can turn, a circle of, 2.2 meters, more or less. How do I use that information to determine, and I'm not going to use words probably that are the ones that you would prefer that I use, but how do I use that information to calculate the steering angle that it's capable of turning so that I can reprogram my low-level steering controller?
That's not the graphic that we were looking at meeting.
Wait a minute, what's going on here?
I'm seeing a Slack channel.
Oh, they're starting to move. I tried to zoom in and it doesn't want to respond. So anyway, on Sunday, September 26th, I said, if you go out and you measure your forward velocity, rotational velocity, and run through this calculation, your steering is coming out at 52.2 degrees. Is that what you're asking? So I went through the whole process here and said, this is what you do. If you measure the forward velocity, measure your rotational velocity, and run it through this equation here, it'll tell you what angle it thinks that is. Now this is just taking it from a single point by taking your plots and looking at it. What's odd is here, I can't see my screen anymore. But anyway, that doesn't matter. I'll see if I can continue on here. So it only tells you at a single point what it thinks this quote angle is. And I don't know if that angle is, it's technically the vehicle angle that it's measuring, but I don't know if that matches if you run wheel odometry, and mine has wheel odometry. It also tells you the angle as you're turning. So I don't know if those two numbers match. And I don't know if either one of those numbers are going to match what you'd put in for a steer angle request. And I've gone through and modified my code, and I had at the point where I could take it out and drive it and try to verify that. Then I got distracted by this trying to move the trying to move the GPS location around.
Well, let me come at it this way. If I'm at position 1.1 and I go into RViz in the future and I click and I say I want to go to 2.2, it's going to calculate an angle, and it's going to calculate a command velocity angular value and send that to my low-level steering controller?
Well, technically, the way yours is set up is going to send an angle down to your low-level steering controller. It will not send rotational velocity.
Well, I didn't say.
Well, I think you did just say that. So I just wanted to point out that, no, it's not the rotational velocity you're sending down a steering angle. We have it on video. We can go back to see what you said, but I think, I just wanted to clarify that that really is an angle that the tab blender is putting out.
So if it's going to put out an angle, I'm trying to figure out how to change my low-level controller to accept the range of values that it's going to receive from ROS, so that I can accept what it's going to send it, assuming I use something as simple as RViz to say go from 1.1 to 2.2.
My first thought is, don't use RViz and specify navigation goals. Do it at a lower
Well,
level.
I'm just using that as an example, Jeff.
But you're always trying to go way beyond this. You can say, let's give it a GPS waypoint. Now, what you need to do, either use your joystick or type in a command velocity message from the command line to do this. So let me go back and ask, the first one the first bag file you posted that I was doing all these calculations on, was that done from a joystick, or was that done from specifying goals? I know the last one you just posted was from a joystick, because we just talked about the fact how you're driving it from the joystick. What I could do is I could take either one of your bag files and I could write a node that says take rotational velocity out and forward velocity out and calculate the angle, and have it just create something called angle, and we can plot that and see what it's doing. So by using the data you've already created, we can go look at that. So while you're driving around in the two circles, we can have it say, here's the angle I think I am moving at right now. And instead of, see, before I just went in and manually grabbed any point on a circle and said, tell me at that instant, what is the angle? But it should be possible to just write a simple node that says, tell me, create an actual plot as the entire time you're driving around, what's the steering angle, or what's the retrieved angle that it thinks it's going at. And then theoretically, what you want to do is calibrate your steering to that. So you'd say, if it says, oh, the example I came up with, I said it's turning at about 50 degrees. So what I would do, I would say the number coming in, tell it that it's 50 degrees, which whatever that is in radians, and then just scale that to your steering at, well, let's see, if as you're doing that, let's see, your steering, you cranked it over. I guess I'd have to go look at your steering. We have to pull up that plot and look at it. I don't have, this computer won't do that right now, but basically you just want to find out what angle does it think it's turning at, and then use that angle as the input. So you want to scale the angle coming in. Let's say it's 50 degrees. You want to scale that to whatever you think the wheels, see, as you're returning, I guess this whole thing about the fact that joystick is not a square pattern introduces more complications, because we don't know exactly as it was turning where your joystick was set. I guess if I pull up my plots here, I could go look at that and get a good idea of what that was. But it's really just a matter of saying, if the thing is turning at this, it's reporting that it's turning at this angle, then you want to have the number coming in match that. So you want to just pick a number coming in, and that's going to turn the steering to a certain amount. And then as you drive it, it'll report the angle coming back out. You just want to get those two to match. And that probably doesn't make a lot of sense, but So what I'll do is I'll go through and I'll write up that node to extract your data out and tell us what the output angle is. And we can look at the command from your joystick at that point, and we can look at your steering values, and you can plot all at the same time and see what that's doing. And I think that might tell us something at that point. And on mine, I was going to yeah, I put in the code to dump out my odometry angle that it thinks it's going at, and then I added the code to generate this angle in real time that I'm talking about. But I totally got sidetracked and didn't go out and drive that, so I could go out and try that again too to see what that's doing. So I've got code written that's actually it would generate that in real time and put that out as a topic. But I can take your bag files and extract that data and create another topic called angle or restored angle, retrieved angle, recovered angle. I can call it recovered angle. And then we can see what that's doing. And at that point, we know what your two steering sensors are doing. We know your steering joystick is set at, and we can measure the diameter of the circle by your GPS plots. So I think there's enough data there with what you've already done that we can extract that back out. And then once I figure out how to write a node that will take forward velocity and rotational velocity and put out angle, then we could just make that a node and you can run that, and so it'll just always generate this in real time. So as you drive around, it'll create it anyway.
Okay.
So I'll put that on my list to do. I'll fire up my plot juggler and then try to write a node to do that, to recover your data. I've got two bag files from you, so whichever one, I can run it on both of them and see what they do, and so I think that'll work.
The topic that you are writing that mix up all the values will go to 2000 characters.
It will do what?
The topic that you use to use the Plot Juggler, that you add all the values inside one topic, will go to 10,000 characters.
Oh, like an array you're talking about? No, what I'm suggesting right now is that we just create a new node that will just subscribe to two different things. It can subscribe to, say, /speed, and subscribe to what's the other one we want? We have to get a rotational velocity from somewhere, either from the IMU, or I could recover it from GPS or whatever, and it'll just publish one single topic saying recovered angle. So it has nothing to do with those big arrays that I was doing before. On my particular case, I put low-level code to do that, and yes, I added it on the end of my 100 and some characters, and I just put that out as an array. So if I know that it's array entry 24, I can plot that on mine to see it. But for Al, we'll just for Al and for the real world, we can just recover it directly from the ROS topics that are running and publish a new topic called recovered angle.
Okay.
And which goes back into the point, as I was pointing out on the list last night, I ran into a problem where on Plot Juggler, I had this weird plot that was there. Let me see if I can get back to that. Where is that? Because I did this plot that I said here. Let me back up here a second. I said I was going to use this plot, but when I went and looked at it, it's old enough. I only have about half of my topics that got logged into a bag file. So I spent about an hour digging through all my files. So there's another problem with Plot Juggler. So when I created this, I opened a file of some random time. I don't know what it was. And I plotted this data and did a screen dump. But there's nowhere on the screen that says what file did I start with. So I've got a nice picture, but I have no idea what file I created that from. So it'd be nice if somewhere on here they've got enough room, just put a thing saying the input file was this. Now maybe they don't do that because you might be able to open 2 or 3 files with Plot Juggler and put them all together. I don't know if you can or not. So anyway, this file was old enough that it didn't work. So basically I dug through until I found this one, which was giving me, I was doing some driving around here and I could actually see some difference here. Because if you look at this, say this point right here is probably the back of the vehicle and this point's the front of the vehicle. And likewise, this is always so hard to figure out. So this point here is either the front or the back, and then this point is either the front or the back. So I just found another plot that would work. But the problem is it has all this extra junk on here that I didn't want any of this stuff. And maybe that's just what it was. I didn't want the stuff leading into it. So on my playback, I said, start at something like 120 seconds and go for 70 seconds. But when I did that, that screwed up my plots going into Plot Juggler. So that was another thing I ran into, is trying to figure out what to do with that. So it either has to do with what order I started up in, or I'm not sure what it is. I was going to go back and try it again and say, start up my new node that's generating new data, and then start up the playback so it's running, and like 60 seconds or so into it, I can say now start recording, and then hopefully that'll fix my timing problem. Because otherwise, when I go into let's see, when you go into Plot Juggler and try to drag this slider back and forth here, it's supposed to tell you on the plot where you are, but that stopped working for some reason, and I haven't figured out exactly what I did. I think it's because I cut a piece out of the middle of it, or because I started my node before I started the playback. Something screwed it up. So I think if I do that, I can make that work. So on Al stuff, what I'll do is write a new node that says subscribe to these and create this topic called recovered angle, and then have it publish that, and then I can start up my start up the record. And what it'll do is it takes his original file and adds in the new topic. So when I'm done, I've got a new bag file that's got that stuff in. So I can pull that up in Plot Juggler and then compare everything together at the same time. So I can look at the output angle, I can look at the joystick input, I can look at the all the values all the way through. I can look at his 2 steering sensors. So that'll give us data we can plot out and look at. So that a while back I said you can do a playback and a record at the same time to add data into it. So, and Juan said, why would you want to do that? Well, this is exactly what I'd want to do that. So I'll create a new bag file with new data added onto it. So I'll try to do that today.
Thank you.
So I will tell you, last week I received the dongle to use the STM32 chips. This week I was working in trying to upload the code to the STM32 board, not the discovery board that you have, another board, using the STM32 IDE. I didn't know, but when you receive the dongles, you have to update them to the last version of firmware to be able to upload to the boards. So as I skipped that part of the procedure, I was working 3 hours and I wasn't able to do it. And at the last time, I reboot my computer, and when I plug it, I see the window that tells me to update the code of the firmware of the dongle. And I updated, and I was able to upload a very easy blinking code from the STM32 IDE to a blue pill. But I didn't get time to test it with the to the STM32F4 board. I think that I will test it the weekend or next Wednesday that I'm working in it. But it was pretty easy, and it was I think that maybe it will have a difficult learning curve, because you have to set up the pins in a graphic way, and this is the first time that I'm using it. But I find it very interesting working with that IDE.
Just a couple of comments. When you upload to your new board as opposed to the blue pill, it should work exactly the same way. But just keep in mind, if you've got an LED on that board, it'll be on probably a different pin than what the blue pill was. So keep that in mind. But you're just connecting directly to the programming pins of the processor. So it doesn't really care, there's no extra stuff in between there. So it should, whether it's talking to the blue pill or talking to the F4 board, it should upload just fine. It's just
Yes.
when you, in your IDE, make sure you get the pin correct for the LED,
Yeah.
so you can tell what's going on.
Yes, yes. We were in I don't know how to explain, but we were getting run and run and run because we couldn't find a tutorial of but we get one in Spanish that was very good. And I think that it was very straightforward. The problem was that I didn't follow the path that the tutorial tells. I jumped the part of I didn't see the windows that was asking me to update the dongle.
Okay, the other point, let's see, what was I just going to say? Oh, you keep mentioning you have to go back and change the pins on the IDE. I'm still thinking you don't have to do that. It's good to know how to do it, but I don't think you have to change anything there. If it already says pin, say PD0 goes to your motor PWM, then you simply have to hook your motor up to that pin on the board. I don't think you have to change anything in the software. The software has already defined all of those pins on the board. You just have to wire up to the correct pin to make your stuff work.
Yes, I'm not sure the process, how the process is, but when you are booting the system and it recognizes the board, you have to tell it the board again. You cannot skip the part you are telling which board you are going to work. As the blue pills are not the boards that are manufactured by the STM32 IDE builder, you have to use another. But I think that if you use the same boards that they sell, it's much easier to do that. But I wasn't able, because I built up the project from zero because it was a blinking project. So you have to choose new STM32 project, and then that leads you to select which board you are going to use. Then you select that you are going to use the blue pill board, and it's open the STM32 chip, and you have to open the pins that you are going to use, because the pins are closed, and they are also closed the ones that use the dongle to communicate to the blue pill. So you have to open the blue pills TX and RX pins in your project too. It's not so easy sometimes, but I think I understand it, how it works. I don't know how I will translate that to the other boards, but I will try.
Instead of selecting a board, just tell it you want to select the microprocessor. So just tell it whatever the microprocessor is on your F4 board, because it's just trying to pre-map a bunch of pins for you, which you don't have anyway. It's trying to say, oh, this pin is actually connected to the push button and this one's connected to the audio driver. Well, you don't have any of this stuff anyway. So just instead of selecting a board, say you want to select the microprocessor and give it the processor you have, and it's going to pop up and say, okay, you're ready to go. And I think that's what you need to do. You might have to go into the existing project, and if it's has references to that board, because typically what you would do is, if you are going to use the board, you would say, go ahead and say load the STM F4 discovery board, and it's going to pop up and say, oh, these pins are already pre-assigned to certain things. typically you just click on a button that says throw all that out anyway. So you don't really care what they're, and then you remap them yourself. So you can just skip the whole step of specifying the wrong board and throwing out all the mapping. You can just say, pick the microcontroller, and I think that will work.
I will try.
Oh, I have to remember here that I see we got two chat things. I gotta remember to save the chat. I can't remember if the chat automatically gets saved, so I've been saving it every time just to make sure.
Yes. Today I have another meeting and I saved the chat. It download all the chat and the audio file. Chef, I will have to leave too. So
Okay.
see you next week. Thank you.
Well, maybe I will continue on with my explanation of my GPS remapping, and then when I'm done, I'll stop the meeting. So anybody that wants to can go back and watch this later.
Okay. Sorry, but I have to go to the doctor.
Okay.
Bye.
So I'm going to go on and talk about my effort to remap the GPS. And the problem is on the GPS, you can specify a transform, but it doesn't seem to, the transform tells you where your GPS is located on your vehicle in relationship to baselink, but it doesn't, in our case, since we're using Matt's GPS to ODOM program, it doesn't subtract off that offset. So what you're really getting is it says, here's my XY offset from my origin, but that has nothing to do with baselink at that point. So we've decided that we probably need to go into the GPS ODOM program and specify where the GPS is located. We basically have to pull up that transform between the GPS and the ODOM. And in my case, they're both right on the center line. So I've got an offset, is that X or Y? X, Y, Z. So I've got an X offset of 0. If we go with the concept of Ross, where forward is X. So I've got, since they're both on the same center line, I've got an X offset of 0, and my Y offset front to back, I measured. Well, I've a slightly more advanced case where I got a front GPS and a back GPS, and from the back one to the front one is 0.5 meters, or no, excuse me, 0.75 meters. So it's 75 centimeters from the front to the back, but from the front to baselink, it's 67 centimeters, or 0.67 meters. So somehow you have to subtract that offset off there. So by the time you're done, it's reporting your XY location in the terms of baselink. And to me, it seemed like the easiest way to do it was right in the code. It's got a function that goes out and says read, or it says take the latitude and longitude coming in and take your latitude and longitude offset that you have specified as a constant, and it passes it to a function. It's called like latitude, like LLA to XY or something like that. If we pull up the code, we can see that. In fact, I can show you right here. Let's see, how do I make this bigger? I don't know if this will show up or not, and I can't figure out how to make the screen any bigger. There's a function here, it's called LL2XY, and that's contained in that library in the, I think it's called geodetic transforms or something. And you pass in the your new the latitude and longitude we've just read, and you pass in the origin, latitude and longitude origin that's specified in the code. I should pull up the real code here. I don't know how long it'd take me to find that. And basically it returns back an XY location, but that's the XY location of the GPS, not of baselink. So I thought, well, what we'll do is we'll subtract that number off, and you can't just subtract the value of the GPS. You can't just subtract, in my case, 0.67 from it, because as you rotate, that's not taking the rotation into account. So I thought, well, what you need to do is you need to take in the heading of the vehicle, and you need to do a sine and cosine on that. So it's like translating in graphics or whatever you do, and you have to, if you want to translate a point from one point to another, you take the existing point, you take the angle of the vector, and you take the sine. In this case, it says take the sine and multiply it by the length in that direction. So in my case, 0, 0 means I'm right on the center line. And so once it comes up with the new corrected value, then you subtract that off the original X point. So I come in here and I say the heading, the sine of the heading times my length, and subtract that from the value it just gave me in the thing above here. And then likewise on the one for the latitude one, again, it takes the heading and I take the cosine of that and multiply that by the length between the two and subtract that from the value that it gave me. So I thought that would do what I wanted it to. So if I come up here and this is the, see, how can I can zoom in. This is the original plot of the front and the back antenna. So when I started off, the back antenna was here and the front antenna was here. And as I drive around and come over here, as I start to turn, you can see the front antenna does not follow the path of the back antenna. And when I come over here to, let's see, how do I do this? So as I come along here straight, everything's working just fine. And then as I start to turn, see the front of the vehicle is out here, the back of the vehicle is here. So as I start to turn, the front of the vehicle follows this path and the back of the vehicle follows this path. So when I come to a stop, see, here's the back antenna, here's the front antenna. And then I started backing up. So you can see this one, the front of it backs up here and this one backs up here. So the thing was, I was trying to correct for that. So if I say, since we're just looking at that one, here's a, here's the zoomed in version. This is the original, the thing we're just looking at here. This is the line coming in on the GPS. So again, the front antenna takes this path out here. The back antenna takes this path out here, which stops, the back stops right there and the front stops right there. So this is the offset that GPS is seeing, or that, yeah, by reading the GPS location, it's showing me that. And then if I come over here and zoom in, he says, so now we're coming along here, the front antenna, is taking this path, the green one here, until I come to a stop, and the back antenna is taking this path until I stop. And now by putting my correction, both of these are vertically at the same point. So it fixed it in one direction, yet there's still an offset between the, in the other direction here. And as I was writing this up, I realized that offset is the same as the, on this graph, the X offset between this point and this point. I simply moved these two to the same vertical point, but the X offset is still off. So I've still got a problem there with that. And here, let me look at another, come on. Oh, I had to back up one. So this is an example down at the bottom of the screen here where, again, I was coming straight down. I come down and the back antenna stops there and the front antenna comes all the way down, stops here. So over here, after running my correction, now they both stop vertically at the same point because I've subtracted off that 0.67 meters from the antenna to base link. But see, there's still a horizontal or an X offset here. And I think, again, if you look at here, it's the X offset between here and here. So somehow I'm missing part of the equation because I need to rotate both of them and not just the one. And the reason only one of them gets rotated right now is because, back to, how can I, come on, there, that made it bigger, sort of. So down here where I'm saying the distance from the front GPS antenna to base link is 0.67 meters, and it does its calculations, and sure enough, that does work. But for the other direction, I say take the sine of the heading, multiply it by 0, which means I'm always going to get 0 out of this line right here. And since I'm not getting 0, that means I apply no correction to that. So I just have to figure out, there's one more step here. I just got to work through this and figure out how to get that to work. So once I do, I think that will then see how to get back to where I was. I think I can correct, like say in this case. Because when I'm done, I want both of these points to follow on top of each other. So it says, another point to mention there, this is actually the front GPS and the back GPS. It has nothing to do with base link at this point. When I'm all done, I have to just specify front antenna to base link and then base link to the back antenna. And right now, this is just simply from the back antenna to the front antenna, because it's given me, both of those are giving me an absolute reference on the face of the earth. So I don't know if any of that makes any sense or not, but that's what I've been working on. And maybe if I play with it a little more today, I'll get to the point where, let's look at this one again. So on this one, theoretically, this orange line and the green line should be right on top of each other, either follow this path or follow this path, whichever, by the time I'm done. That's the goal. And if I can get the two antennas to report the same value, then I can say, what's the front antenna to base link? In which case, then the front antenna or the back antenna will be both on top of base link. The results will be on top of base link, and then all three of those values should line up as I drive around. So that's my goal at this point, is to do that. And let me kick out of here, stop sharing. And this was an old plot. I think I mentioned earlier, this was an old plot because I couldn't get the one that I wanted to use. It was old enough, it didn't have all the data in there. So I need to go through and figure out, how do I get those to match? And then what I need to do now that I've got all this stuff working, I need to go out and create a new plot and have it generate the stuff on the fly instead of having to play back a bag file, create new topics and re-record that, because that's giving me problems. So once I get all this stuff put in there, I should be able to go out in the front yard and maybe drive around in a circle one way and drive around the circle the other way, and maybe stop that and start it back up and then drive in a square. And then I'll have two reference plots that I can go analyze and try to fix those. So that's where I'm at with that. And I guess I'll report back later how all that went. So I guess I'm signing off.